Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of differentiation. And if I talk about the question that is given to us here from this topic, the question tells us that if y of theta is a function and that function is given to us as 2 cos theta plus cos 2 theta divided by cos 3 theta plus 4 cos 2 theta plus 5 cos theta plus 2. So this is the entire function that is given to us, and the question is asking me to figure out the value of a expression at theta equals pi over 2, and that expression is nothing but double derivative of y plus single derivative of y plus y. What is the value of this entire thing at theta equals pi over 2? So that's the question asked to me. And if I talk about the answer choices that have been given here, the options are half, 1, 3 over 2, and 2. So we need to figure out which one of the answer choices is the correct answer for the value of this expression that is asked to us. Let's try to figure out and let's try to find out which one of the answer choices is the correct answer to the question given to us. Let's see. So first of all, I have been given y of theta as a function. So first, let's try to simplify that as much as we can. So 2 cos theta plus cos 2 theta divided by cos 3 theta plus 4 cos 2 theta plus 5 cos theta plus 2. Now everything I will try to write them in the terms of just cos theta. So 2 cos theta as it is. Using my double angle formula, I can write this cos 2 theta as 2 cos square theta minus 1, and cos 3 theta also I can use the idea of triple angle formula and write that as 4 cos cube theta minus 3 cos theta. So if I use these two ideas and convert everything in terms of cos theta now, so I get 2 cos theta plus 2 cos square theta minus 1 divided by 4 cos cube theta minus 3 cos theta plus 4 cos 2 theta is 2 cos square theta minus 1 plus 5 cos theta plus 2. So we get this entire expression. Now once I get this entire expression, let's try to simplify that. So 2 cos theta plus 2 cos square theta minus 1 divided by this entire thing I can write that as 4 cos cube theta minus 3 cos theta plus 4 times 2, which is 8 cos square theta minus 4 plus 5 cos theta plus 2. Now, if I try to simplify it further, I can write it in the form where the power that is greater should come ahead. So I can write 2 cos square theta plus 2 cos theta minus 1, the whole thing divided by 4 cos cube theta. Then the term of cos square, so I can write 8 cos square theta. Then I can use this cos theta is present both the sides. So plus 5 and minus 3 will give me plus 2 cos theta. And minus 4 and plus 2 gives me minus 2. So we get this entire expression now in terms of cos theta. Now what I will do is I'll try to simplify that further. But to make it more easier for us to understand, let's just substitute cos theta as x. And once I get it simplified, I'll resubstitute x as cos theta. So basically y of theta, which was this entire function, now becomes y of cos inverse of x, I can say, which is equals to 2x square plus 2x minus 1, the whole thing divided by 4 cos cube, so 4x cube plus 8x square plus 2x minus 2. So I have this entire thing now here with me. Now further what I can do is let's try to see if I can make this cubic powered expression the highest power of 1, which is 3. Can I make this, or can I dissolve this entire expression into two parts such that if I can divide it with 2x squared plus 2x minus 1. So let's try to do long division and understand if I can factorize or factor out this same term from the denominator so that that term and this term get be directly cancelled and I can simplify that. So if I do that, let's try to divide it by long division. 4x cubed plus 8x square plus 2x minus 2. If I'm dividing with the numerator 2x square plus 2x minus 1, I'm just dividing it to just figure out whether I can write this expression as a product of two fractions or two terms in which one term would be this. So if I try to divide it, taking my first terms, if I divide them 4x cube divided by 2x square, x cancels, x square cancels, I'm just left with 2x. So I get it 2x, I write it 2x. Once I get my first term, I'll multiply that first term with all the three of them. So 2x into 2x square gives me 4x cubed. 2x into 2x gives me 4x squared. And 2x and minus 1 makes it minus 2x. Now once I have this, I'll change my signs because I'm subtracting the whole expression. So I'll change signs of everyone. This and this cancels. 8 minus 4 gives me 4x squared. 2 plus 2 makes it 4x minus 2. Now again, if I divide the first two terms, first term from here and first term from here, 4x squared divided by 2x squared cancels and just 2 is left. So plus 2, so 4x squared, then 2 into 2x, so 4x, and plus 2 into minus 1, which is minus 2. So since I'm subtracting this again, I'll cancel all the terms, so nothing is left, it's 0. Basically, that means this entire term which I've written, the cubic term, is divisible by this upper term. Or I can write this entire term, cubic term, as the first expression with which we divided, the divisor times the quotient. Plus remainder means basically which is 0. So I can just write this denominator as this now. So y of, I can write theta, but theta I've substituted as cos inverse x. So I can write that as y of cos inverse x as 2x square plus 2x minus 1. The whole thing divided by 2x square plus 2x minus 1. And the quotient I got it was 2x plus 2. Plus 0 doesn't matter because adding 0 doesn't make any difference. So it will be this term only, and from this I can directly cancel out this. So I'm just left with 1 over 2x plus 2. So I've simplified now. Now once I've simplified, I'll just resubstitute my x, or I can say my x as cos theta, right? Because I have substituted cos theta as x. So if I resubstitute, I should resubstitute x as cos theta and not cos x is equal to theta. So I'll resubstitute here. So I get y of theta as 1 over 2 cos theta plus 2. If I try to simplify, I get 1 over 2 common, cos theta plus 1. Now once I have cos theta plus 1, I can use the idea of double angles again. 1 plus cos 2 theta was 2 cos square theta. So it basically becomes half angle. So 1 plus cos theta. Instead of 2 theta, if I have theta here, it basically makes it cos square theta over 2. So I get this. Now once I get this, I can just write down and simplify. This is 1 over 2 and 1 plus cos theta makes it 2 cos square theta over 2. So I get y of theta simplified to become 1 over 4 cos square theta over 2. And cos square theta over 2, if I take it up, I get 1 over cos square theta over 2, and 1 over cos theta is sec theta. So it will basically become sec square theta over 2. So I have this expression simplified altogether now, which is sec square theta over 4. Now, once I have that, that's my y function, which was given to me in terms of theta. So I have the y function with me. Now let's find y dash and y double dash, and then we have to add all of them at this angle theta equals pi over 2. So let's find y dash now. So I know already y is 1 over 4 sec square theta. So if I find y dash, sec square theta over 2, not just theta. So if I find y dash, 1 over 4 is a constant. Derivative of sec square theta over 2 using chain rule, I'll consider this sec theta over 2 as x. So it's basically finding derivative of x square, which is 2x. So I can write this as 2 and x I've assumed sec theta over 2. So I have to further find the derivative of sec theta over 2. Finding the derivative of sec theta over 2, I'll again assume that this theta over 2 is nothing but x. So derivative of sec x is sec x tan x. So sec theta over 2 and tan theta over 2. And since I've assumed this theta over 2 as x, I have to find the derivative of that. So 1 over 2 is common and derivative of theta is just 1. So we get this entire thing. So I get it. 2 and 2 cancelled again. So 1 over 4 sec square theta over 2 tan theta. So that's my entire expression for y dash. Now y dash once I have, let's try to figure out y double dash because we want the second derivative also. So 1 over 4 is already a constant here. And if I have these two terms, these are basically in the product form. So if they are in the product form, I can use the idea of derivatives where I can find u derivative of v plus v derivative of u. So using my product rule, I can write this is sec square theta over 2 as it is. Derivative of tan theta over 2 is again sec square theta over 2. And since instead of theta over 2, I have replaced that with x to further find the derivative of theta over 2. So half and 1 plus tan theta over 2, I'll write it as it is. Sec square theta over 2, if I see, again I'm assuming this entire theta, sec theta over 2 as x, so it's x square. Derivative of x square is 2x, so 2 sec theta over 2 times derivative of sec theta over 2 is sec theta over 2 and tan theta over 2 times derivative of theta over 2, which is half. So you get y double dash turning to become 1 over 4. 1 over 2 sec raised to 4 theta over 2 plus 1 over 2, and this 2 gets cancelled. So I have nothing left. So just that. And here I get sec square theta over 2 tan square theta over 2. So we get this entire thing. So this is my y double dash. Now the question tells me you have to find the value of the sum of these entire expressions at y equals or theta equals pi over 2. So let's first find theta equals pi over 2 and find all the three expressions. So if I put at theta equals pi over 2, what does this become? It becomes x square. Theta is pi over 2, so pi over 2, which is pi over 4 and 4 in the denominator. So 1 over 4 sec pi over 4. So cos pi over 4, we know it is cos 45 degrees, which is 1 over root 2. So sec pi over 4 is just root 2. So sec square pi over 4 will become root 2 square, which is just 2. So it is half. So I have the first value, y dash. At theta equals pi over 2, if I put it, sec square pi over 2, which is pi over 4, tan of pi over 2, which is pi over 4 again. So 1 over 4, sec square pi over 4 is again 2 because root 2 squared is 2, tan pi over 4 is just 1. So 2 over 4 is just half again. And the third expression, if I see it's y double dash, 1 over 4 as it is, half sec square pi, sec raised to 4 pi over 4. So it's basically root 2 raised to 4. Then I have sec square pi over 4, which is root 2 squared, and tan square pi over 4, which is just 2. So 1 over 4, 1 over 2, root 2 raised to 4, which is 2 raised to 2, which is 4, plus root 2 square, which is 2. So from here, I get this is 2, 2 plus 2 is 4, 4 over 4 is 1. So I get y double dash also. 1, y dash is half, and y is half. So I have all the three of them with me now. If I just add all of them, this was 1, this was half, this was half. So 1 plus half, which is nothing but 2. So if I see the answer choice that matches here with the question, it is option D. So D becomes a correct answer for this question that was given to us here. I hope you have understood how to solve this type of questions. So first we just try to simplify this expression as much as we can. Once I simplified it, I just put the value of theta as pi over 2. I got y dash and y double dash as my values, and once I added them, I got the correct answer choice, that is option D. I hope you have understood how to solve this question. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE so they can also take the benefit from these questions that we are solving. Thank you.